Show that root 2 is irrational. Okay. Solution. For this, first we assume root 2 is rational. Okay, rational is nothing but it will be in the form of fraction, p by q form. Okay, so root 2 is equals to a by b. This is rational number and this is irrational. So we are assuming root 2 as rational. Okay, a and b, where a and b are coprimes. Coprimes means they do not have common factor except 1. Okay, means they do not come in any other table or they do not have any other factors except 1. Okay, so root 2 is equals to a by b. Now squaring on both sides. Squaring on both sides. Squaring. Here also squaring. This square and root gets cancelled. You will get 2 is equals to a square by b square. Now cross multiply. 2b square is equals to a square. Put it as first equation. Now b square is equals to, this 2 goes in the denominator, a square by 2. Here 2 divides a square. See, a square is divided by 2. It means 2 is dividing a square. So it also divides a. Okay. So we can write it as a is equals to 2c. So at the place of a, we have to substitute 2c in first equation. For example, the question is root 5. Prove root 5. Okay. For that time, you have to write a is equal to 5c. Our question is root 2. So we are taking 2c. Okay. So this is the difference. For root 5 is irrational, we have to take here a is equals to 5c. For root 2, we are taking a is equals to 2c. Okay, so equation 1 is 2b square is equals to a square. 2b square is equals to a is 2c whole square. 2b square is equals to 2c whole square means 2c into 2c. 2 square is 4, c square is c square. Okay, 2b square, this 4 goes here in the denominator. 2b square by 4 is equals to c square. Now cancel 2 ones are 2 2s are. So c square is equals to b square by 2. Here 2 divides b square. B square is divided by 2. It means 2 divides b square. So it also divides b. Therefore, both a and b have 2 as a common factor. Here 2 is dividing a square and also a. And here also 2 is dividing b square. So that means 2 is a common factor for both a and b. But this contradicts the fact that a and b are coprimes. In the starting we have said that a and b are coprimes. They do not have any common factor. But 2 is a common factor for both a and b. So this contradiction has arisen because of our assumption that root 2 is rational. As we assume that root 2 is rational, so our assumption is wrong. Thus our assumption is false. So we conclude that root 2 is irrational. Second question, prove that root 3 plus root 5 is a irrational number. Okay, first we assume that, let us assume root 3 plus root 5 is a rational number. Rational number is nothing but it is in the form of p by q, fraction. In a fraction form it is. Okay, so root 3 plus root 5 is equals to a by b. Whenever there is two roots, okay, we have to square on both sides. Squaring on both sides. Okay, root 3 plus root 5 whole square is equals to a by b whole square. This is in the form of a plus b whole square because we can't add these two numbers. So we have to apply formula here. A plus b whole square, that is nothing but a square plus b square plus 2ab. A is root 3 and root 5 is b. Okay, is equals to a square by b square. Now this square and root gets cancelled. Square root gets cancelled. Okay, this is 3 plus 5 is equals to 2. Root 3 into root 5 is nothing but 3 5s are 15. Root 15 is equal to a square by b square. 3 plus 5 is equal to 8 is equals to 2 root 15 is equals to 8 plus 2 root 15 is equals to a square by b square. Now 2 root 15 is equals to a square by b square plus 8 will become minus 8. Take this to the right side. It will become minus 8. 2 root 15 is equals to, this is fraction and this is number. So take LCM. LCM will be b square. A square minus 8b square. Okay. So 2 root 15 is equals to a square minus 8b square by b square. Root 15 is equals to a square minus 8b square by 2b square. This 2 goes in the denominator of that side. Okay, 2b square. A square minus 8b square by 2b square. This one is a rational number because it is in fraction. Okay, so this is a rational number. This leads to the root 15 is a rational number. That means root 15 is also rational number because root 15 is equals to rational number. But we know that root 15 is irrational. This contradicts the fact that root 15 is an irrational number. Hence, our assumption is wrong and root 3 plus root 5 is an irrational number. Okay, because this is rational and this is irrational. So, we can't say root 15 as rational as root 15 is a irrational number. Prove that 3 plus 2 root 5 is the irrational number. Let us assume 3 plus 2 root 5 is a rational number. 3 plus 2 root 5 is equals to a by b. This is rational. So, a by b means that is in fraction. So, this is rational number a by b. Now, take these 3 to that side. It will become minus 3. So, 2 root 5 is equals to, now take LCM. LCM will be b, a minus 3b. Okay. Now send this 2 to the denominator. 2 root 5 is equals to a minus 3b by b. Root 5 is equals to a minus 3b. 2 goes in the denominator. So this is a fraction and this is irrational number and this is rational number. A minus 3b by 2b is a rational number. This contradicts the fact that root 5 is an irrational number. But we know that root 5 is a rational number. Okay, this is due to our assumption that 3 plus 2 root 5 is a rational number. Hence, our assumption is wrong. Therefore, 3 plus 2 root 5 is a rational number. In this type of question, we have to square both sides. Then you will get one root value. So, that we have to prove root 15 is equals to a rational number. Okay, see here. Root 15 is a rational number. In this question, we already have one irrational number. So, we will send all these numbers to that side. First send this 3. It will become minus 3. Okay. Then send 2 to the denominator. Okay. You will get root 5 as a rational number. But we know that root 5 is a irrational number. So, our assumption is wrong. Therefore, 3 plus 2 root 5 is rational number.